And with that, welcome Phil Roth.
All right, thanks. Yeah, thanks a lot. Like you just said, I'm Phil Roth. I'm a data scientist at Endgame. I'm going to talk about just the role that data visualization can play when you're building machine learning models. An alternative title might just be screenshots of this internal visualization tool I built to test malware score, along with a lot of lessons I learned building it. That'll hopefully help you guys out. At the end, I'll also kind of go through some resources for some data visualization tools that I think I really enjoy using, and maybe you will too. So, like I said, I'm Phil Roth. My background is in physics. I used kind of a machine learning algorithm getting my PhD in physics. I moved on to make images out of radar data, but then I definitely wanted to get back to machine learning, and so that's why I came here to Endgame. All right, so let me talk about the kind of the two products that I work on, one external and one internal. Malware Score is a machine learning first solution built for detecting and preventing malware. It's a model that operates on Windows executable files. It's based on static features, and it just tries to classify whether these executables are if it thinks they're benign or malicious. It's very lightweight. It executes very quickly. It's deployed to customer machines, and it's also available at VirusTotal. We're proud of those scores, and you can go get them publicly at VirusTotal and dig around them and see in the scores and see how they work. So Bit Inspector is an internal tool for communicating progress, soliciting feedback, and identifying errors related to Malware Score. It was kind of like a tool that I built while building Malware Score to help me. There are two, okay, so these are the tools I used to build it. I'm a Python guy, so I kind of built this web front end in Flask. It kind of uses a little bit of D3 on the back just to get some of the visualizations that I couldn't get in pure Python plotting. And then it also generates some static plots in Matplotlib and Seaborn. It also connects to multiple internal endgame data and processing resources. And that was kind of also one of the advantages that I didn't expect when building it, is that the code for this web front end is in Python, and it uses a bunch of stuff. So that code is now available to all the endgame employees. And so when someone comes to me and says, how do I grab the data for this sample? Or how do I upload this sample to our processing pipeline? Well, Bit Inspector does all those things, and the code is there, so I could just refer to them to, well, this is how Bit Inspector does it. So you can go ahead and grab that code and do that on your own. So yeah, that was one of the unexpected advantages of building this. There are two kind of main pages in Bit Inspector. There's a little bit more, but the main interfaces are showing all the information it has about one Windows executable file. And that's kind of, some screenshots of that are shown here. You have the hash and a link to the VirusTotal. And then you also have all the different versions of Malware Score and how those versions all scored the file. And then on the right, you kind of have a visualization that I'll go into later, but shows some of the features that Malware Score is based on. And this is, again, a great resource if somebody, one of our domain experts, has a file and wants to know how our model scores it and how it scored it in the past. Then the other kind of way to look at Bit Inspector is a model page, and it shows all kinds of information about one version of Malware Score. There's some static files that are all available there for other people in the company to download and use, and then lots of plots about the performance of that model. And I'll get into what those plots, well, right away, I'll get into those plots. Whenever you're talking about visualizations to evaluate machine learning models, there's kind of two basic ones that you definitely need to be using and that are in Bit Inspector here. And that's the ROC curve. The ROC curve and the area under the ROC curve is really the main way that we at Endgame use to kind of compare models to each other. And it's a great way to know how well you're doing. I'm not going to go through it in detail here, but I just wanted to show it as a resource and then also include maybe the code that we use to generate our ROC curves here. And I'll make these slides publicly available, so if this can help anybody out here. And then also the confusion matrix, that's kind of shown on Bit Inspector, and that's just a table where the columns represent the predicted class and the rows represent the actual class. And then we kind of show this for all the data and also for different subsets of data. But when the actual labeled class matches up with what is predicted, that's going to be on this diagonal here, and that's when you're doing a good job. and then the other diagonal is going to be when you're doing a bad job. And just by looking at the numbers in that confusion matrix, you can calculate some true positive rates and some false positive rates over the whole data and then in certain subsets. And then just as a resource, that's kind of the Python code that we use to generate those static plots. All right, so with those kind of basics laid out, let's kind of get into what I view as the role of data visualization, or how it's helped me as I build a machine learning model. And the first idea is feature experimentation. If you're visualizing your features about all the samples and all the data that you're kind of train on, it's very helpful. When you're paging through all your training set and you're looking at these pages that kind of show the features, it kind of gives you a sense for what is in your data, what a sample might be, and why a model might be scoring it one way or another. I'm not going to get into too much detail about what these features are. They've been talked about before. I'm just going to refer to a link there that kind of describes what the sliding window byte entropy is. But I will say that just visualizing that byte entropy this way, it really allowed us to kind of really quickly get a grasp for what might be in the file. High entropies kind of show up high on the y-axis there, and empty data shows up very low on the y-axis there. And so just at a glance, it kind of gives you an idea of what the sample is that you're dealing with, and then might give you a sense for how it's being scored. Yeah, so not only getting a sense for what the features look like for all the data in your training, you can also use data visualization to get a very quick sense of how your model is performing. And like I said, the way we do that is using a Roth curve where we can compare models to each other, but then also showing the scores for different samples throughout time. Another great way to use data visualization is to find problems and red team your model. This has been invaluable to us at Endgame. I mean, it's kind of a big, scary step when you've built a model and you think it's doing well, and you want to move forward and you want to go ahead and deploy it on customer boxes. I mean, you really need to build confidence in what you're doing, and that you want to build confidence in the model and that it's going to do what you want it to do. And I found, and we at Endgame have found, the best way to do that is to kind of open up the model to the rest of the company and kind of say, hey, beat this model, show us where it's lacking, and show us where it's going wrong. And so we made an interface in this bit inspector in order to do that. Domain experts can come in here, and if they know about a hash that's usually classified wrong by other AV vendors, they can plug it in there or upload the file itself. That's a great way to obtain more data and make sure that everything that we know about is in our databases and in our data pipeline. And then on the sample page where it shows all the scores through time, there's also an interface for clicking, if you're submitting a bug, if a sample is scored maliciously and it's benign, then you want to report it and give it to us and keep all those and then we keep all those bug reports in our own little database and feed those scores back into our training data. This is kind of a little bit like active learning, and active learning is more about building a model to suggest to domain experts which samples they should label and which would best help the model. So we're not doing that step yet. We definitely want to get to that level. But right now we're just kind of soliciting feedback and asking our domain experts to red team our models. The thing that's going to come from that whole process is, problems like subsets of data, subsets of samples that we're getting wrong. And so once you find those things, you want to, change your labels, you want to change your model parameters, you want to work on that and start getting that subsample correct. What data visualization can do then, or what we do in Bit Inspector, is to then track that solution over time as we train more and more models. We want to make sure that all the problems we fix stay fixed and we don't break them at some point. And breaking out all our samples into different subgroups and then plotting their confusion matrices and histograms of their malware score, that really helps us be confident that once we've solved a problem, it stays solved. So I'm going to get into kind of how Bit Inspector evolved and how different people in the company started using it. But before I talk about that, I just want to talk about what you do when you're spending time improving your visualizations. And in my mind, the things that you're improving are the explainability, the trustworthiness, and the beauty of your visualizations. So what do I mean by those three things? First, explainability is kind of like, can this visualization be understood on its own? If the creator of the visualization is not in the room when the person is looking at it, can the viewer still understand the point that it's trying to get across and all the data that is in it? There are some basic things that you can do to increase the explainability, like label your axes, show the units, and make sure it's titled and make sure everybody knows what is going on there. And those are things you definitely should be doing. But I just wanted to highlight some extra steps you can take to increase the explainability of your visualizations, and almost like stress them because I don't do them enough. And that's adding annotations and also adding explanations in readable prose that allows people to just read and figure out what you're trying to get across. A great example of annotations especially is this XKCD comic that you can get right there. It's a visualization of the temperature of the Earth over a long, long period of time. And I just love this visualization for all the annotations it shows. And it just gives you a great sense for what Randall Munro is trying to show you. All right, so what do I mean by trustworthiness? That just means, can you trust the source of this visualization? It's very easy to generate maybe a chart in Excel or something, or make a plot in Python and stick with the defaults. But that's not really going to make the viewer trust that you know what you're doing. In order to get that kind of trust, you want to add some styling, and this is especially true for like media outlets. You want to make consistent styling and make it look like you know what you're doing. And I just thought The Economist does a great job at that. Lastly, beauty. I'm not really going to try and define that. A lot of people might have different opinions on what data visualizations look the best. This is one of my favorites from a site, pudding.cool, that just shows the number of unique words used in different rappers in their lyrics. Yeah, I really like it. I think it looks really cool. It definitely takes a lot of time to generate something that's really catchy like this. And that's one of the ways that you can spend time improving your visualization. All right, so let's get into who I was building Bit Inspector for in this long journey of building Malware Score Up. The first audience is definitely myself. When I was building Bit Inspector, really I just wanted to convince myself that I was doing something useful. At that level, you don't really need to be you don't really need to be spending a lot of time on your visualizations. You can, leave the explainability low and all those other things because you know exactly what you're after. You have a question in your head and you're trying to answer it by generating a visualization. And you're going to immediately get that feedback. And so you can pretty much leave the defaults on. So you want to convince yourself that you're doing something useful. And so I'm just going to use this as an excuse since I have a background in physics for dropping a quote from a famous physicist. But, you want to convince yourself, but you are actually the easiest person to fool. And one of the ways that you can fool yourself is by continuing in this model building process. You're trying something, you're looking at the results, and if something looks wrong, then you think about it and you fix it and you try something new. And you're always going through this process, the scientific process, this model building process. But at some point, something might look right, and you're going to break out of this process, and you're going to say, I'm done, everything's great. But there's still many things that could be wrong, and you could be fooling yourself. There could be two things wrong that are just like canceling each other out and making like just one of the metrics that you're following look right. And that's how you can fool yourself. And the important thing to do is to look at good results and then sit back and say, well, how could these still be wrong, and what else can I test? All right, so you've built a model, you have some visualizations, you have some metrics that are convincing yourself that you're doing things right. The next audience is kind of the rest of your team. And here the purpose is to communicate what you've done and get feedback on what you didn't consider. At Endgame, we have a bunch of data scientists. They have a lot of different backgrounds. They've trained different models on all kinds of different data sets. And it's those various backgrounds that are those varied backgrounds that are going to give you, new ways of looking at the problem. And you're going to get valuable feedback by doing that. But you need to put a little bit more work into your visualizations in this case, and definitely add context, like where the sources of data are, what the model parameters that you went into the model training, what they were, because your data science team is going to be very interested in those things. Pretty much everything is the same for domain experts, but in this case, the context that you're adding is going to be a little bit different. For me, it's like PE header information, hashes, links to virus total, those sorts of things. And once you've added that and opened these visualizations up to the rest of the company, then you're going to get valuable feedback from your data science team and your domain experts. All right, so you've done all this. Now Malware Score is an important part of your product. It's been getting thrown out to the public. But now it's important that managers and executives look at it and figure out what the progress is and what this current state of the art is and where the problems are. And this is the point where it's really important to ramp up the explainability of your plots. People who are looking at it are not going to have that background in machine learning to know what everything means. At various times, Mark or Jamie have come over and sat down next to me and been like, what is this plot? What does this mean? And, I'm happy to give it to them and explain it to them. But I kind of see that as a failure on my own to make the visualization truly stand on its own. The last audience is the public. We have a technical blog. I like it. It's great. We put a lot of work into trying to explain where we're coming from and the techniques we use to build machine learning models. And not only, you want the explainability of the plots at that point to be very high, but then now this is the time when you want to ramp up how the visualizations look and how nice they look. All right, so that's just some general thoughts. Now let's get into kind of a tour of some of the tools and resources that I use and that hopefully you can use and that you might find useful. Tim Hopper, a data scientist that I definitely respect, made a webpage called pythonplot.com that kind of compares the plotting syntax of various Python plotting packages to each other. So there's some certain tasks, and then he accomplishes those tasks in a variety of Python plotting packages. And those are listed there. It's a common complaint in Python that the plotting tools aren't that great. They're pretty verbose. They're not as great as maybe some other statistical languages. And I think this is one step in trying to improve that and maybe get the Python plotting community just behind one package. Jupyter Notebooks, I use these all the time. They're great for exploratory data analysis, and you can look at a plot and then change something about how the data is gathered, regenerate that plot right in the notebooks there. So I use notebooks all the time, maybe not as much as I should, just because typing in them, I don't have all my nerdy Emacs key bindings, and so I get frustrated at typing in these little boxes. But they are great for just like keeping the data reading code right there, and so that you can keep rerunning it with new ideas. Kibana is something that we at Endgame, we've known about it for a while, but we're really getting into it very recently. Kibana allows for rapidly building and constantly updating dashboards. Building these dashboards that constantly update themselves. There is some extra work that goes into building a Kibana dashboard. Mostly you need to translate your data from wherever it is into Elasticsearch because these plots are kind of based on Elasticsearch queries that are then just displayed and constantly updated. Shout out to Daniel Grant, who made all of our recent Kibana dashboards, which are, again, getting us more and more confident in Malware Score. And I just wanted to highlight this thing that Daniel told me recently. And it just shows it kind of opened to me another role of data visualization. It's publicizing what you've done to the rest of the company. And sometimes that's really important. Sometimes you've made something or accomplished something, and it's really hard to express. But once you've made a data visualization that looks awesome, then everybody's going to be going there and saying, yeah, now I start believing in this. D3, I mentioned that as something that Bit Inspector is built on. A lot of data scientists maybe have a background in R or Python, and so JavaScript is definitely something else to learn. It takes a while to ramp up on that. So the cost is high in making D3 visualizations, but the payoff is the customization possibilities. You can really do anything you can imagine in D3. And so, if you have the time, if you have the inclination, I think it's definitely worth learning. But just realize that you're not going to be able to do exploratory data analysis. You're going to need to put a lot more work into your visualizations to make them look exactly like you want. Yellowbrick is something that I should probably get more into. It's this project made by District Data Labs in DC. What it is, the idea is to have pre-baked model evaluation visualizations that adhere to the scikit-learn API. And you can kind of see the example of one of them here. You have your training data. If you're using scikit-learn, you already have your training data in this kind of form where you have lots of feature vectors and labels, and you're feeding those into scikit-learn anyway. So it's great to just use Yellowbrick to automatically generate visualizations that are going to tell you more about your model. 2 weeks ago or so, Google released Facets, which I was really excited about. It's early. I don't totally understand it. I want to work with it some more. But right now, I think this is really it's the best option for truly responsive exploratory data analysis. I've always been a little bit skeptical of getting anything done, very responsibly, like changing something and getting a plot, and keeping up with the speed of you thinking of ideas and exploring the data. But I think this Facets project is really getting to the point where you can explore your data just interactively. And I do have time, so I guess that means I'm going to try a demo of Facets, but things could go totally wrong, and no guarantees. All right, so this is a notebook that's kind of shipped with the Facets project. It's based on an open source data set. Right here, that data set is kind of read from the internet and then converted to JSON here. Right here is kind of all the magic. You have this, your data in a JSON string right here, and then you just feed it into this code, and that kind of generates this interactive visualization. So this is some example data that Google kind of, it doesn't ship with the project, but ships the code to read that data. All right, so then what I did was kind of took some of my data and tried to explore it. So I wrote some code to kind of take some of the samples that we have and feed them into PE file. And then I can generate some section sizes and some file sizes and a bunch of other information, like things that definitely are features in our model. And so I read that data into the notebook here, and then I just kind of take this magic after Facets is installed in your environment and everything. Then I fed this in here, and the resolution isn't great, but let's start clicking around. So you can see you can change what the colors represent. For us right here, right now, it's the label, and that means this red is malicious data and this yellow is benign data. And then the cool thing is you can break that data out based on different features that you fed it. So I'm going to do file size here, and that doesn't look good. All right. It looks like the resolution isn't going to let me do great things, but So, I guess that looks a little better. I think what it's doing is the display here, like each dot can also represent something in your data set. So if it is an image, like that dot can be the image that you're looking at, but that's not helping us here. So let's get rid of that. It's not great. So I don't know, so you can start fooling with this and breaking your data out. I think it's going to be very useful for me in taking malicious and benign data and just breaking it out and automatically generating histograms and seeing what might be a great feature. Let me try one more thing. Yes. So like the overlay ratio, a PE header kind of defines how large your file is, but a lot of times there's some extra data on the end, and the ratio of how much extra data there is to the actual size of the PE file is one of our features. I kind of broke it out based on that and the file size, and I was just fooling with this maybe a week ago and kind of found a group of data, and it looks like exactly malicious data there that has a certain file size and a certain overlay ratio. So this tool really allows you to kind of break out and see those groups, and there might be something special about that group. I'm not sure there is. I mean, it's big enough that there's probably a lot of things in there, but I think the next step is to kind of dive into there and see if there's anything interesting or special about those malicious files, and then start looking at that. All right, that went okay. So that's it. Thanks a lot, and I'll just open it up to questions now.
I have a quick question for you. So let's say you have a bit of polymorphic code. Is that going to change the malware score you assign to the code? And if so, do you want that change reflected in the visualizations you produce as a result?
Malware score is totally based on static features. So if there is something unpacked or unzipped in running, we're not going to look at that. We're just going to see the data as it is on disk. So no, it's not going to change the score. But we're ramping up our dynamic analysis. We want to maybe get some of that involved in a bigger model. But right now we were focused kind of on models that can be shipped to endpoints and evaluated very quickly. So we haven't built like deeper inspection models based on dynamic analysis like you described. All right, thanks.
All right, thank you, Phil, and everybody remember to follow him on Peerlist.
Okay.